In this video, we are looking back at combining like terms. We first defined like terms as terms having the same variable raised to the same power, and we have the examples of 5xy to the second and 7xy to the second. They both have an x raised to the first power and a y raised to the second power. So these are like terms. To combine like terms, first we're going to identify the like terms, and then we're going to either add or subtract them as necessary. So we have the example 3x squared minus x plus 7 plus 5x plus 2 minus 2x squared. So I used a combination of shapes and colors to identify the like terms. So here we have a 3x squared and over here a negative 2x squared. Remember that every number has a sign and every sign has a number. So these are the only x squared terms that I have. So I'm going to use a different symbol for my x terms. And I also used a different color. So I'm using like a little V or part of a triangle for that. So I have a negative x here and a positive 5x here. So those are the only x terms I have. Then for the constant terms, I just went ahead and underlined those. So we have a positive 7 and a positive 2. Now it's just a matter of arithmetic. 3 minus 2 is 1, so I have 1x squared. Negative 1 plus 5 is positive 4, so I have plus 4x. 7 plus 2 is 9. So all of this whole expression here, simplifies to be x squared plus 4x plus 9. Now in our notes, we had 3 more examples where we took example 1 was a very long list of terms. We had x squared terms, we had y terms, we had constant terms, and we had x terms. So here we identified the x squared terms using the little box. We identified the y terms using the V. I use like a part of a circle or a smiley face to get the regular x's, and then again I underlined for my constants. Then again, it's just a matter of arithmetic. You use the coefficients and you add or subtract. So it's negative 3 plus 5. Negative 3 plus 5 is 2. And what are those things? They are x squared. So we write 2x squared. Now when you're writing this in standard form, your x's all come before your y's. So I'm going to skip this y and I'm going to skip the constant and go all the way down here to negative 2x. Negative 2x minus 3x. Negative 2 minus 3 is negative 5, so we end up with a negative 5x. Now I can go to my y terms. I have a plus 4y and a plus 2y, so 4 plus 2 is 6. So I end up with a 6y term. Then my constant terms. I have a negative 4 and a positive 4. But negative 4 and positive 4 just make 0, and we don't ever write just plus 0 all over the place. So it just disappears. So all of that stuff right there became 2x squared minus 5x plus 6y. In example 2, we now have a lot of a's and b's over here. So I identified all my a terms. I had a negative 5a, a positive 3a, a positive a. I had some constant terms of negative 2, negative 12, positive 1. And I had some b terms, negative 4b, positive 6b, negative b. So just like A comes before B in the alphabet, we're going to take care of our A terms first. Negative 5 plus 3 is negative 2. Negative 2 plus 1 is negative 1. So that's where the negative A came from. Now we go to our B terms. Negative 4 plus 6 is positive 2. Positive 2 minus 1 is 1. So that's where the plus B came from. Then we have negative 2 minus 12, which is negative 14. And we take negative 14 and add 1 to it and get negative 13. So this whole expression became negative a plus b minus 13. In our final example, we have a lot of terms. We have m cubes, we have an m, we have a constant, some more m's, we've got an m squared, another constant, and some m cubes. So remember, like terms have the same letter and the same exponent. So negative 8m to the third power is the same as negative 3m to the third power. They have the same letter with the same exponent. This one has an exponent of 2, so he's not like these cubed terms. He's different. Then we have an m, so we have an m, which means we have an exponent of 1. So we have a plus m, a plus 5m, and a negative 2m. And then we have the 3 constant terms. Whenever we are writing our answers in standard form, and all the letters are the same, then all you have to look at is the exponent, because the higher exponent comes first, or the bigger exponent. So negative 8 minus 3 is negative 11. So our m cubed term is negative 11m cubed. Now we go to m squared. There's only one of them. Can't combine it with anybody, so we just write it down. Negative m to the second power. Then we have our m terms. 1m plus 5m is 6m. 6m minus 2m is 4m. And then our constants. Negative 2 plus 1 is negative 1. Negative 1 plus 5 is positive 4. So all of that became these 4 terms. While these 3 here all have an m, they don't have the same exponent, so they are not like terms. So this was combining like terms.